let's go ahead and get started. Welcome to everyone. I'm Mike Erickson, Associate Vice President for Community Engagement at Internet2. And I'd like to welcome you to today's webinar entitled 5G Advanced and an Outlook on 6G. As we hear from our presenter, please feel free to post questions in the chat portion of your Zoom window. We have reserved some time at the end of the presentation for interactive question and answer and discussion. And a reminder that we will be recording today's session for sharing out later. We are pleased to have with us today Amitava Ghosh, a Nokia fellow that works as part of the Nokia Standards and Strategy team. Today's presentation and discussion will be on Nokia's vision for 5G Advanced, how it will be a stepping stone for 6G technologies, and work being done by the Next G Alliance in setting some audacious goals that will put North America at the forefront of developing a global 6G technology. So welcome to Amitava.
Good afternoon, and thank you, Mike, for the kind introduction. And thank you for inviting me to speak at the Internet 2 6G seminar. So the subject of my talk is 5G and on the path to 6G, where industry alignment and collaboration are key to make it a success. So the first slide, which shows from research to standards, so how we do it in Nokia. We innovate, we invent, and we create and drive open end-to-end network technologies and systems. So initially, at the start of each G is a decade, and we start first with technology scouting, where we attend academic conferences, we do university collaboration, guest lectures, industrial workshop. We form partnership for various research projects between industry and academia, which I'll talk later in the presentation. We also do internal research, demos, proof of concepts, technology radar, industry and market trend. Then we do systems research, so scouting industry needs by talking to various customers of ours. Business case, we do business case analysis and we do detailed research targeting standardization. That's one of the goals. And finally, we are involved with various standards organization. We do standardization, and after standardization done, it is commercialization. So these are the steps from research to the standards. Moving along. So Nokia's main goal is to help the world act together. So we create technology that help the world act together. So we are involved in global standards for the global market. We are involved since global standards enable open and interoperable interfaces. We adopt global standards in all regions, voluntary consensus-based standards. We avoid artificial disruption. We have inventor-friendly policies, promote innovation. So that is because Nokia is member of 500 standard development organizations and associations. We have a global network of experts which represent Nokia standardization. As you can see this eye chart on the right, that what are the standards we are engaged in, like 3GPP, O-RAN, various bodies like 5G, ACIA, NextGA, HexaX, and you name it, we are involved. So the next slide is about global standards is key to the success of cellular technology. And each cellular technology each new cellular technology is, each G is a decade worth, right? So we started 2G in the 80s, 90s, where we just had voice and SMS. Then the 3G was in the 1990s, broadband data and low-cost voice. Example of 3G is HSPA, HSPA+, CDMA, EVDO. Those are the examples of 3GPP. Then 4G was MTC and video, which is WiMAX, LTE, LTEA, low-cost data, zero-cost voice. And this 4G was made successful. The data part was by the invention of the iPhone, which totally transformed 4G. Now in the 2000, this decade or 2000 decade of 2010, 2020, we are in the 5G era right now. So what is 5G good for? It was industrial IoT, interactive video, low-cost video, zero-cost data, zero-cost voice. Then was MTC, optimized MTC. We in 5G NR we showed how a air interface, OFDM air interface is flexible. We introduced new band, both FR1, which is the sub 6 gigahertz band, and FR2, first time millimeter wave band in 5G. And 5G comprises of 5G advanced and 5G. So 5G started standardization in around 2015 timeframe. We are now doing release 18 of 5G. The next decade, 2020 to 2030, will be the era of 6G, which I'll describe later, where we connect worlds, where we have massive scale AI and sensing holographic video. So the upshot of this slide is that each new generation is about optimizing the new use case of the previous generation to reduce cost and introduction of new use cases. For example, in 5G, we introduced this URLLC, ultra reliable, low cost solution. But URLLC, like industrial IoT, all the verticals has not taken off. But 6G, in 6G, I think all these use cases will be optimized. So 5G will be successful in the 6G timeframe. So some of the use cases like URLLC, ultra reliable, low latency communication. So 6G will not only build on existing technology, it will radically transform what a network can do. In doing so, we'll liberate the human potential inclusively and sustainability. So what we have been talking in 6G is the unification of our experience across three worlds: the physical world, the digital world, and the biological world. So this is the upshot of this slide. The next slide is about 5G is expected to become a general purpose technology platform, right? So for examples, like in video, in 5G, we support high quality video, and 5G Advanced, which is going right now, which is release 18 and 19 of 3GPP. We have this item called extended reality XR, where we have a fully immersive user experience while on the move. And in 6G, we'll extend XR to have the holographic experience. So in 5G, we have digital twin of an engine. In 5G Advanced, we can have a digital twin at a larger scale. And in 6G, we'll have digital twin of cities and even humans with real-time synchronous updates. The other example is localization and sensing, where currently we can do data communication control. We can provide precise location and timing services that complement GNSS. So indoor location accuracy of less than 10 centimeter or so in 5G Advanced. And in 6G, we'll combine network, or we'll combine communication and sensing technologies together, which we call it network with the sixth sense. So if you look at the timeline for 5G, we started deploying 5G with extreme mobile broadband in 2019 timeframe. This is deployment, release 15 deployment, but release 15 started standardization in 2015 timeframe. Ultra reliable low latency communication, it was finalized in release 16. Release 17 We have wider ecosystem expansion, which is 2022. Currently, we are doing release 18, 5G Advanced, which is 2023, 24. And then the release 6G studies, we are currently doing 6G study, but in 3GPP, the 6G will be initially introduced in release 2021 timeframe. And then the release 21 will have 6G standardization, and the deployment will happen around 2030 timeframe. So moving along, first, what we say, Rome was not built in a day. So we have to realize the full promise of 3GPP or 5G through various evolution or various releases of 3GPP standards. So release 15 was about extreme mobile broadband, which have been deployed currently. We had 5G NSA, non-standalone. And now, 2019, we have 5G standalone system. Industrial IoT, we have seen a lot of proof of concept, but it is not taken in a commercial scale, right? But it will happen around 2023 timeframe. Release 17 was augmented for wider ecosystem expansion, which I'll talk about, and release 18, 5G advanced, which I'll talk about in the next slide. So 5G advanced, it has 4 pillars. So it is still this EMBB, URLLC, and MMTC. So while today's 5G network are starting to bring the future to life, 5G advanced and 6G are in great demand to fully realize it. That is the key. So first I will talk about experience. For 5G advanced, rather we are looking for reliable data rates practically anywhere in the order of 100 megabits and bounded latency values in the range of 5 to 30 milliseconds. This is required. This is required to support new emerging application like XR and cloud gaming. So I think if you have seen the movie, excuse me, Ready Player One, that is an example how cloud gaming and extended reality will work. This is the 5G advanced is the first step towards it. We talk about edge computing, optimization in 5G advanced, mobility performance improvement, and of course, we continuously improve our MIMO schemes. The next is extensions. So extensions means how do I improve the uplink coverage? Uplink coverage is always the bottleneck. So in release 18, we are trying to improve the uplink coverage by using new modulation techniques by at least 2 to 3 dB. We have enhanced MTC scheme, RedCap for sensor. RedCap means reduced capability UEs. So because we are using this reduced capability UEs for sensors in release 18, we are looking at 5G satellite networks. Now, a lot of people like the billionaires are investing in non-terrestrial communication, NTN, through satellites and HAPs. And release 18, we are introduced 5G NR for drones, also how to improve capabilities for LEOs and HAPs, mainly for LEOs. Then the expansion. In release 18, we propose to introduce the new services of precise positioning and resilient timing as a service. The main motivation for this new extended 5G services ought to be an alternative and resilient solution to GNSS. It provides resilience, it provides indoor service, and power consumption to terminals can be much lower. Finally, we have the last pillar, which is the excellence. What we are doing is excellence. We are looking to improve network energy savings. How do you do network energy? As an example, so if we have a lot of microcells and if there is no traffic on those cells, we can shut off those cells. So that is one example of network energy savings, because sustainability is one of the main topics right now. Then we have the other example, which is very, very important, is AI/ML, end-to-end AI/ML. So we are looking at deep RX receiver AI/ML, especially with respect to beamforming. How can you work with CSIRS using AI/ML technology? How can you do channel estimation using AI/ML technology? How can you enhance positioning technology in classifying long line of sight versus line of sight using AI/ML? So that is the excellence part. So moving along, I'll go through 5G advanced experience. So extreme MBB experience with bounded latency with high data rates and enabling industrial IoT for FR2. As I said, with this, we need high quality end-to-end XR experience, enhanced QoS, QoE management, faster connection setup time, reduced interruption time, and enhanced battery life. So examples of these candidates are, we have talked about XR for which was introduced in release 18, mobility enhancements, MIMO beamforming enhancements, URLLC for frequency range 2 in millimeter wave, edge computing enhancements. What is the example of 5G extension? So one of the examples, what are the feature candidates in release 18? As I said, red cap enhancements, which we call it NR Lite. NR Lite over non-terrestrial networks and HAPS. Uplink modulation enhancements, we need this because we want to extend the uplink coverage. Uplink heavy TDD, 5G UAS, which is 5G drones. So there was drones introduced in 4G LTE also. We are trying to replicate in 5G NR. Then we have sidelink enhancements, which includes multi-hop and unlicensed, and sub 5 megahertz for verticals. So these are the examples of 5G extension, which I talked about. One thing to watch is how to extend the uplink coverage. On the expansion side, I already talked about in release 18, we are proposing to introduce new services of precise positioning and resilient timing as a service. So example of positioning where we can get less than 10 centimeter accuracy is, we are looking at carrier phase positioning method, low complexity positioning, side link positioning, and timing resiliency. Next, we are talking about 5G advanced operation excellence. So as I said, in release 18 features which was added was data exposure and analytics for AI/ML, network slicing enhancements, and then the most important part on the excellence, we are looking at this deep RX receiver, which I'll talk about, that how to introduce ML in RAN, from CSI improvement to channel estimation using AI/ML. So parts of the receiver, we are looking at how to introduce AI/ML in the receiver, not in the transmitter. Next, we move on to slide 12, which says, what will 6G be used for? So we can think in terms of three categories. One is the augment human intelligence. So the first is about creating and consuming new digital worlds, virtual or digital twin worlds. There are some examples of use cases in the category which I talked about in the previous slide, like the holodeck. We talked about holodeck, that although we can't implement the whole holodeck in release in 6G, we can implement parts of it. We can create high resolution mapping of the physical world to create digital twins world, which will consume enormous amount of bandwidth, so you need to explore new spectrum opportunity. Designers creating new products can make real and imaginary, mix real and imaginary object to see what that design looks like. So you can design a city or a factory in the digital world, then you can implement it in the physical world. Next category is augmenting our intelligence. So far, you have used the network for information. If we do not know something, we look it up in the Google. As AI becomes more powerful and widespread, we look to machines to provide us with intelligence, not just information. We can learn a lot about ourselves through body sensor, network-based monitoring and analytics can make the security lines in the airport thing of the past. So that's why we talk about intelligence through digital assistant, automatic security, and in-body monitoring. And lastly is augmenting human control. This is the last category. It about controlling our automatons, our robots. We'll see many more of them and they'll become network orchestrated. We can see drone on robot swarms, which we can see right now with UAVs, and there are air taxis, we call it UAM, urban air management, where we'll see air taxis. So this will become normal going to 6G. So next slide is about what is the enabling foundation of the future. What we have been talking so far is really the unification of our experience across the three worlds, the physical world, the biological world, and the digital world. We need several new emerging technologies to achieve that, which in turn will drive new connectivity solution. So we need new sensing and actuation technologies to create the digital world and manipulate the physical world from the digital world. The computing requirements will increase enormously, and distributed computing will be the major new theme. So devices may not be able to meet all compute needs and will rely on combination of edge cloud and local near device computing. So for example, XR will heavily depend upon edge cloud and local near device computing. We'll need knowledge system that will store and process data and perform reasoning, prediction, and planning. Creation of digital world will require new ways of providing information to humans. So 6G will not only provide the connectivity, but also maintain synchronization across the system to create a holistic experience. So this is the Nokia perspective of 6G. So 6G technologies, we said, hey, we promoted this from 2019. So we had 6 elements of 6G technologies. We have new spectrum technology, AI native air interface, network as a sensor, extreme connectivity, cognitive, automated, and specialized architecture, and security and trust. So these are the 6 foundations of technology from Nokia's perspective. And as you can see, I will take the next G Audacious goals and then I will compare how this line up with what the world is thinking. So now you are saying that why do we need 6G? What services do we expect from 6G? So here is a few examples. So say for augmented reality XR. So 5G, we can do low resolution, high level tasks. In 6G, we expect to do high resolution, multi-sensory detailed tasks. And we can do digital co-design where two users in two different places can design a system or design a network or using these digital twin worlds. Telepresence capacity, we can do high video quality, limited scale. We can do mixed quality holographic video in 6G. Then dynamic digital twins and virtual worlds. Difficulty in 5G, we don't have that kind of bandwidth where we can do real-time multisensory mapping and rendering. In 6G, we are expected to do it. Data center, can we make it wireless? In small data center, we need to make this, we have to have very large bandwidth to handle it. 5G, no, 6G, we can do it. Zero energy devices, now with sustainability in mind, zero energy devices, we using backscatter communication is very important. And this will be tackled probably in release 19 of 3GPP, but this will be an important area in 6G. Then AI will become a staple for 6G. So I will talk about new spectrum technologies for 6G. So let me go back. So this slide shows the various layers. We have the basic coverage layers, which is the low bands below 1 gigahertz. Then we have the basic capacity layers, which is the mid band. And so why in 5G became very popular because of the C band, right? Because we didn't see the uptake in millimeter wave band because of the C band, and mid band is very essential because ultimately what we need to do, we need to reuse the cell site instead of putting a new cell site, but we can have more improved coverage and capacity to the operators. Coverage and capacity are the key metrics. And that's why we see EMBB, proliferation of EMBB. So what in 6G is the golden band? So we are looking at this 7 to 20 gigahertz band. I don't know exactly what band, but this mid band, we call it 7 to 24 or 7 to 20 gigahertz, will be very important in 6G. Then we have the capacity enhancement layers, which is millimeter wave band. There is a lot of unlicensed band left, which is not used, 57 to 71 gigahertz in 6G. And then there will be peak capacity layers, which is the D band, which we call it sub 6 gigahertz band, the W band or sub terahertz band, we call it. D band, W band, but I think there are a lot of talk about the sub-terahertz band. But essentially, we have a lot of bands. We first focus on the mid band, the sub-terahertz band. Initially, I will say, will be mainly used for backhaul, for densification of the network and millimeter wave band. That is my take on it. So 6G will have probably new bands, which we'll see in WRC 23 and 27, which will include probably some sub-terahertz band, the mid band 7 to 24, 7 to 20 gigahertz is very important, and also some low bands. Moving forward, now this 6G, how can we do 6G AI native? Is it possible? So we have started exploring that in 5G Advanced. So this is the classical transmitter and receiver where we have the encoder, symbol mapper, modulation, waveform. The figure, however, does not include the MIMO precoding, but it should be included in there. We have and then we have the receiver, which is channel estimation, equalization, symbol demapping, and decoding. So in 5G Advanced, we are trying to replace the receiver. We call it deep array receiver, while machine learning is replacing individual processing blocks. Like we are replacing the CSI arrays, we are replacing the channel estimation, the different beamforming approaches in 5G Advanced. So then we'll combine some of this block channel estimation, equalizations, symbol demapping, we call it machine learning deep RX. Then in 6G timeframe, we'll have deep TX and deep RX, where machine learning design part of the PHY itself. How practical it is, how feasible it is, I don't know. But this is the vision that there is a roadmap to optimize 6G AI native interface. Whether it will come to fruition, we don't know. But The AI ML is very important, and we are doing research and studies in that. Next is, how do we combine communication and sensing, or radar and communication technology, and which will be useful for uh, various purposes. So with increasing network densification, use of wide bandwidth, massive MIMO beamforming, and sophisticated AI-based signal processing, built on the system for communication radio sensing from the same infrastructure is a new possibility. So integrating communication and sensing, lot of talk about it. So it can create new services, both for indoor and outdoor, for operators to offer to customer. Optimizing the air interface for joint communication and sensing can result in significant deviation from current 5G specification, that a new generation of air interface will be more appropriate. So to do that, we have to look at various waveform multiplexing. Will the sensing waveform be different from the WaveTM waveform for communication? How can we do the frame structure for sensing and communication? How do you do resource allocation? How do you do high precision localization in non-line of sight communication? So these are the answers we are researching while we are doing network with a sixth sense, or combining communication and sensing technologies. The next is the 6G extreme networks. So some of the examples of industrial IoT. This can be a network by itself, localized, highly localized network. So we are offloading the load from micro or macro networks to these local area networks, which we call is extreme networking, in-body networks, in-vehicle networks. These are the examples of, of extreme networking, which we are also researching. So next is the slide. So I'm not an expert in architecture, but we are striving towards this architecture goals. So it started with standalone 5G course, which eliminates the hardware-centric centralized architectures of the past and embraces a cloud-native distributed infrastructure for building and operating networks. The approach uses microservices running on a service-based containerized architecture that enables service delivery all the way to the far edge of the network. So we'll have a cloud platform which is public, private, and hybrid. Premises will be edge and metro premises, and containerization and serverless. As I talked about, it will embrace a cloud-native distributed infrastructure for building and operating networks. It will use microservices running on a service-based containerized architecture that enables service delivery all the way to the edge of the network. We'll have flexibility in function placement, peer-to-peer and subnetworks, and of course, improved slicing. So we have to minimize function and include automation, and we have to scale it so it can be scaled from globally and locally with more than 100 gigabits per cell and less than 0.5 millisecond. Latency, of course, it will be robust and secured, which is truly anywhere and multi-connected. So this is the Nokia's views on 6G timeline, which I have discussed earlier. So release 15, 5G MBB, URLLC, 5G advanced. We are building on the 6G concept right now, if you look at the upper. And then we are also doing this ITU, where we'll do the requirements around the 2025 time frame. And this is 6G requirement and 6G study. And the first peak in 3GPP will happen around 2028 kind of time frame. And we see commercial deployment around 2030 time frame. And as I talked about the WRC World Radio Conference 23 agenda item on new bands for 6G, as well as WRC 27, and talked about the new band, especially the mid bands, 7 to 20 gigahertz, and the sub-terahertz band we'll talk about probably in these two World Radio conferences. Next, I will talk about these regional initiatives. So currently, there are a lot of regional initiative happening. So Next G Alliance, I'll talk a lot about the Next G Alliance and the RINGS program, which is the staple in North America, because this is the first time North America has been actively engaged in a G. We have the HexaX program in Europe. We have in Asia, both in Japan and Korea and India, they are looking at 6G. So what I am talking about, the 6G regional initiative, and there's a lot of coordination between these initiatives, and I'll give you an example of this. So in Next GA, we have these 6 audacious goals of our 6G vision. So Next GA is an artist-driven initiative where there are more than 80 companies involved. It has university, it has government, it is driven by industry, academia, and government, and it has the top priorities for North America's contribution and leadership, and it addresses multiple stakeholder interest. So what do I mean by national imperatives? So in national imperatives, you describe the societal, economic, and governmental factors that drive each objective. We set a bold and clear vision. We describe the change that will be realized with 6G compared to 5G, and describe the unique needs and leadership opportunities from a North American perspective. On terms of application and markets, this is the key markets and use cases we describe by realizing the vision and considering co-dependencies with adjacent industries and groups. And finally, the technology development to identify the technology areas that are needed to achieve success of each objective, explain why these objectives cannot be achieved with 5G technologies alone. Key performance indicators are also identified to set success criteria for technology objectives. So in this Next G Alliance, we have 6 working groups. I am the chair of the roadmap working group. And there's this technology working group, there's the Green G working group, there's the application working group, there's the spectrum working group, there's this policy group. And so there are all these working groups which are working together. These 6 audacious goals was the output of the roadmap working group, a national roadmap working group. So we had these 6 audacious goals, which are trust, security, and resilience, digital world experience, cost-efficient solution, distributed cloud and communication system, AI native wireless network, and sustainability. So in terms of trust and security and resilience, what do I mean? The 6G system will be trusted by people, businesses, and governments to be resilient, secure, privacy preserving, safe, reliable, and available under all circumstances. What do I mean by digital world experience? 6G will support multisensory experience to enable transformative forms of human to human, human to machine, and machine to machine interaction that bring life improving use cases and create new economic values. Cost efficient solutions. So cost efficiency in all aspects of network architecture must be improved for delivering services in a variety of environments, including urban, rural, and suburban, and also supporting increased data speed and services. And 6G distributed cloud and communication systems, where communication and unified computing services work together and create scale across devices, network, computing, resource, and data centers. We talked about AI native wireless networks, which is needed to increase the robustness, performance, and efficiencies against more diverse traffic types, ultra-dense deployment topologies, and more challenging spectrum situation. And finally, sustainability is the key thing in 6G. We should design 6G from ground up with keeping sustainability in mind. So it will reduce environmental impact. So the end-to-end network will be more energy efficient and will implement circular economy principles. The next slide I saw so that we can't do, Nokia can't do all together. We must collaborate to make it a success. So we are driving towards one global standard as it benefits us all. So here on the left, as I showed you, is the Nokia 6 goals, which we published in 2019. Here is the Next G Alliance, the 6 audacious goals. And there's a direct mapping here. So trust, security, and resilience map to security and trust. Digital world experience, it maps to network as a sensor because we are combining sensing and communication technologies. Cost-efficient solution is very much related to new spectrum technologies. Distributed cloud and communication system is related to new networks, which we call it cognitive, automated, and spreadsheet and specialized architecture. This is given AI native wireless network. Sustainability, although not specified in Nokia, it touches everything. Now, what Next Year has done, they have published a white paper back in January, February on these audacious goals. And we have individual white papers on trust, security, resilience, on all of these factors. So we have already published trust, security, and resilience, and distributed cloud and communication system. Digital world experience and cost efficient solution will come out in November of this year or this month. Sustainability and native network, the papers will come out in the January timeframe. In addition to that, the other working group, the technology working group, has published a white paper on this 50 or 47 different technologies. Green communication group has a great white paper on sustainability and green communication. I advise everybody to read that. So moving along also, how do you promote this? So we do Brooklyn 6G Summit in Nokia, which was last month, where with great keynotes, presentation panels, showcasing 6G exhibits, you can go to IEEE TV website and could watch all these great presentations from different segments of the industry, including academia, industry player, government bodies like FCC. And you can see the b6gs.com, you can see the agenda. So this is my last slide. And so standard is a shared vision for a world. From Nokia's point of view, if you want to go fast, go alone. If you want to go far, go together. So standards and working together is a way of achieving this. So we alone cannot create it. We need the world to come together to create the 6G, 5G advanced technology through standards. So first step is translating the standards development goal, real standards, with the help of international standards like 3GPP. We underpin the effort to build back better and help deliver our shared vision for a better world that is better, fairer, and more sustainable. So that's all I have for today. Thank you for listening. I am ready for questions. Thank you.
Yeah. Thank you, Amitava. If anyone has questions, please go ahead and send them in through the chat window. I do have one or two. Amitava, you talked about the architecture of 6G, and then you talked about some of the goals, but I'm wondering about the technological keys, the technological pillars of 6G. What are those, in your view, what are those technological key components?
Yeah, that's a very good question, which is quite speculative, but I think I'll answer that. So I see a couple of technological pillars. First is the AI/ML, end-to-end AI/ML. Can we do deep FDX and Deep RX, especially Deep RX will happen in 6G timeframe. So AI ML is one. The second one, which everybody is talking about, is this new sensing. How do I combine communication and sensing together for applications like e-health and industrial IoT? Can we do that both for indoor, especially for indoor application? How can I combine this radar and sensing technologies, radar and communication technologies? That is the second pillar. The third is everybody needs better coverage, better capacity. How can we do better coverage and better capacity in 6G era compared to the 5G era? Can we get more bands at at this golden band, at the mid band, 7 to 20 gigahertz, where we can deploy MIMO antennas with 256 or 512 elements, but still keeping sustainability in mind. So that's one. Improving capacity and coverage is always the mantra for all G. So that is the third component. The fourth component, I will say, is sustainability. How to do network energy savings and zero energy devices so that, because the ICT industry, it contributes 7% to the GHG industry. So that is other pillar. We should design 6G from ground up. For example, you see, for this extreme MIMO, right, we need a lot of antenna elements. It is not free. You need more, so that will consume more energy. But how do you have better data rates, but while keeping the energy too low? So in terms when the cell is not loaded, can we turn off some of the elements and keep the data rate low? So these are the four pillars, I will say, in terms of technology, what will happen in 6G. 6G will design sustainability by network energy efficiency and zero energy devices, one thing. AI, ML, network as a sensor, that is the third one. And then, of course, we have all this XR and VR experience where we'll have improved capacity and coverage with respect to, because that is the mantra for all generations.
Yeah. Thank you. Another question in your room, in your comments there just recently, you brought up the industrial IoT or Internet of Things, and I understand that that's available potentially. Verticals like industrial IoT are available within the 5G currently, or 5G advanced, but really haven't taken off and been deployed. What are your thoughts about that? Or is that something that will happen within 5G, or we need to wait for 6G for industrial IoT?
What is happening with industrial IoT? I see a lot of proof of concept system, but it has not, although it has the potential of value creation by providing this local area edge networks, which is self-contained for the enterprise, it has not taken up. But what I said in my first slide is that each new generation is about optimizing the new use case of the previous generation to reduce cost and introduction of new use cases. So I think, although I listened to a presentation last time from a 5G ACI member who said that, oh, IoT will be sort of take up commercially in 2023 timeframe. But frankly speaking, I think we'll see large scale deployment of industrial IoT using 5G in the 6G timeframe. So 25, 26, 27.
Very good. Thank you. Any other questions for Amitabha? All right. Any other thoughts before we depart, Amitabha?
It was a pleasure giving this talk. You have any question, send it to me. My email address is amitava.ghosh@nokia.com. I'll be happy to answer the questions. So, but I think 6G will happen and will be deployed commercially in 2030. Now is the time to invent and work together on bringing 6G to fruition.
Very good. Well, thank you. And thanks for being with us today. Thanks to everyone that had attended and was here joining us. We hope that you found this session valuable and informative. And just a reminder that the event was recorded and will be posted along with the slides on the i2 Online website. If you have further questions, please feel free to reach out to us, or Amitava provided his email address. And a reminder that information on all upcoming Internet 2 webinars is available on our events page at internet2.edu/events. So thank you once again, Amitava. Thanks to all of you for attending, and have a wonderful day.
Thank you, Mike, and have a wonderful day too. Thank you.